Good day everyone, you are welcome back to Idowu Maths class. Today we want to consider logarithmic equations. Logarithmic equations are equations that are solved by applying appropriate laws of logarithm. Let's have example 1. Solve log x plus 6 base 3 minus log x base 3 equals 2. Here, you see subtraction in this logarithm. The common law of subtraction will be applied here. So we have log x plus 6 divided by x to base 3 equals 2. There are two approaches to this. You may decide from here to write this logarithm form in indices form. So you have x plus 6 over x equals 3 raised to the power 2, and you go. And you may decide to use another format. Let me finish this. Let's see if I will be able to explain that as well. So if you want to rewrite this logarithm in indices form, this is it. That is where I started with you, writing logarithm form in indices form and indices form in logarithm form. So if you are using that approach, then we go like this: x plus 6 over x equals 9 over 1. 3 squared is 9. So cross multiply, you have 9x equals x plus 6. Collecting the like terms, we have 9x minus x equals 6. 9x, take this positive x to this side, it becomes negative x. So we have 8x equals 6. Dividing both sides by 8, we have 8x divided by 8 equals 6 divided by 8. X is equal to 2 goes in 6 3 times. 2 goes in 8 4 times. And that is our final answer. Let's have this example 2 and see how it goes. Here we write log x minus 3 times 2x divided by x squared minus 9 equals 1. This is in base 10. So far, no base is written at the subscript of the log. We assume it is in base 10. Yes, in example 1, I told you there is another method. If you don't want to write, here we can write this in indices form. Thereby, this logarithm will no longer appear. But if we choose not to write it in indices form, there's another way. Let's see. So you write log x minus 3 times 2x divided by x minus 3 into x plus 3. I want to believe you don't get this confused. X minus 3 into x plus 3 is the expansion of this difference of 2 square. That's why I've taught you difference of 2 square. So it's the expansion of this difference of 2 square. You can see it's in base 10. You can now show your base. And you say it's equal to log 10 base 10. See what I write. In the place of 1, I put log 10 base 10 because the base in the operation here is base 10. Log 10 base 10 means 1. So I use the logarithm to form the 1, which actively represents the figure 1. This cuts this. So we have log 2x over x plus 3 base 10 is equal to log 10 base 10. Remember in indices, when you have 3 raised to power x equals 3 raised to power 2 in indices, because the base are the same, we assume that the powers also are equal. The same thing applies to logarithm. Once the logarithm, once the base are equal on different sides of the equation of a logarithm, then the number of the logarithms on both sides are also what? Equal to each other. The number of the logarithm on this side is 2x over x plus 3, while the number of the logarithm on this side is 10. See, therefore, 2x over x plus 3 is equal to 10. Do you understand? So, cross multiply. You can see 10 is also the same as 10 over 1. So, if you cross multiply, you have 10 into x plus 3, which is equal to 1 times 2x, 2x. Opening this bracket, you have 10x plus 30 equals 2x. Collecting the like terms, you have 10x minus 2x equals minus 30. 10x minus 2x gives 8x, which is equal to minus 30. Dividing both sides by 8, you have 8x divided by 8 equals minus 30 divided by 8. So x equals, what goes in 30 and 8 at the same time? 2. 2 in 30, that gives 15. In 8, 4. So that is your answer, or you leave it as 4 in 15, 3. Remains 3. 3 over 4. So your answer is minus 15 over 4 or minus 3 whole number 3 over 4. That is the end of that question. Let's look into example 3. If 2 log x squared base 2 plus half log x base 2 minus log x raised to power minus 1 whole number 1 over 2 base 2 is equal to 6. Find x. Simple to approach. You send this back to the top to have log x squared times 2. You know, if you write x squared in bracket raised to power 2, it's the same thing as x squared times 2. This x raised to power 2 times 2 is the same. So, base 2 plus log x raised to power half. This half, I take it to the front to form the power of the number of the logarithm, base 2, minus log x raised to power minus 3 over 2, base 2 equals 6. Applying the common law now, we have log x raised to power 4, you know this is x raised to power 4, times x raised to power half, divided by x raised to power minus 3 over 2, base 2 equals, what I told you in example 1, that I applied in example 2, let me apply it again in example 3 for your proper understanding. If I put 6 here, and I decide to write this log in indices form, you know that quite all right. But if I don't want to go that way, see, I will now write 6 log the base, log 2 base 2. So which will be log x raised to power 4 plus half minus 3 over 2 base 2 equals log 2 raised to power 6 base 2. Don't be confused. The bracket up here is indices in disguise. So solving the indices here. Now, observe something there, that we have 2 terms, one on each side of the equation. This side contains base 2. This other side contains base 2. And once the base on different side of the equation of a logarithm are the same, once the base are the same, automatically the number of their logarithms also must be the same. What do I mean? X raised to power 4 plus 2 must be equal to 2 raised to power 6. Look at what I'm doing. 2 raised to power 6 is the number of the logarithm on this side. This is the number of the logarithm on this side. So far they have the same base 2 here, base 2 here. Automatically their number of logarithms are also equal. That's why I equate this to this 2 raised to power 6. But this I simplify it to be 4 plus 2. How? Follow now. Minus times minus here is positive. When you add half to 3 over 2, that gives you 2. You know, you are no longer GS1 students. You are preparing for WAEC or any external exam of I class. 3 over 2 is the same thing as 1.5. 1.5 added to half, what's that? That's 2. That's why we have these 2. X raised to power 4 plus 2 means x raised to power 6, which is equal to 2 raised to power 6. Now, I taught you a law in indices. That law has presented itself again at the end of this logarithm. In indices, we say once we have equal base on different sides of the equation, then their powers also must be equal, as you see here displayed. X must be equal to 2 here. So also, if you have x raised to power 3 equals 5 raised to power 3, because of the equality in their power, then we believe that their base, their root number are also equal. So x equal to 5. The same thing is expected of you to apply here. Because we have equal powers on different sides of the equation, automatically their bases are equal. So therefore, x is equal to 2. That is the end of that question. Let's solve example 4. Solve 3 log x minus 1 equals log 2 minus x all raised to power 3. As usual, once there is no base here, you agree with me we are dealing with base 10. So you have log x minus 1 raised to power 3 base 10 equals log 2 minus x raised to power 3 base 10. It's a standing rule that once we have equal base on different sides of the equation, whether in logarithm or on indices, if it is in indices, equal bases on different sides of the equation, when you have only 2 terms, 1 on each side, then the powers will be equal. If it were logarithm as it is now, then the number of the logarithm will be equal. So far we have equal base, automatically the number of the logarithm are equal. What is the number of the logarithm here? X minus 1 all raised to power 3. What is the number of the logarithm here? 2 minus x all raised to power 3. So you equate them. Say, therefore, because of the equal base of the logarithm on different side of the equation here, you have x minus 1 raised to power 3 equals 2 minus x raised to power 3. It's a standing rule. Now, we are done with the logarithm aspect. We are now facing another rudiment of indices. Don't forget in indices, as I said in the previous example, once you have equal powers on different sides of the equation, automatically the bases are equal. See the equal power, power 3, automatically these bases are equal. See? Therefore, x minus 1 is equal to 2 minus x. Simple. Simple. Those laws are not grievous. They are not cumbersome. You only need to master them. Collect the like terms. You have x here. This negative x, bringing it to this side, it becomes positive x, which is equal to this negative one, take it to the other side, it becomes positive. So x plus s is 2x, which is equal to 3. 2 plus 1, 3. Dividing both sides by 2, you have 2x divided by 2 equals 3 divided by 2. And finally, x equals 3 over 2, or one whole number 1 over 2. And that is the end of example 4. Let's consider this last example that I have for you under this logarithmic equation. Example 5. Find x if log 11x minus 55 minus log x squared minus 25 is equal to log 2x plus 1. Obviously, we are dealing with base 10 here. So we have log 11x minus 55 divided by x squared minus 25 equals log 2x plus 1 base 10 base 10. Because we have equal base on different sides of the equation, then we agree that their number of logarithms are equal, and which is 11x minus 55 all over x squared minus 25 equals 2x plus 1. Let's simplify this. To factorize the numerator here, we have what is common? 11 into x minus 5 divided by x minus 5 into x plus 5. You know, that is difference of two square simplified there, equals 2x plus 1. X minus 5 takes out of x minus 5. So we have 11 over x plus 5 equals 2x plus 1 over 1. Cross multiplying, we have 2x plus 1 into x plus 5, which is equal to 11. This gives 2x squared plus 10x plus x plus 5, which is equal to 11. Are we together? 2x squared plus 11x minus 6 equals 0. So factorizing this or solving this quadratic equation in any way you may like to. So I want to factorize. So we have 2x squared. Finding the two factors that will work here. Minus 12 is the product of the first and last term. I take their coefficient, the coefficient of this alone. So 12 and 1. Yes, 12 and 1 will work. We have plus 12x minus x. Plus 12x minus x will give us plus 11x. Meanwhile, plus 12x times minus x will give us negative 12x squared, which is the product of the first and last term. Minus 6. I'm just referring to that. I'm not reteaching that. I have taught you quadratic equation before now. So, factorizing this, we have 2x into x plus 6 minus 1 into x plus 6 equals 0. 2x minus 1 is equal to 0, or x plus 6 equals 0. So 2x equals 1, or x is equal to minus 6. Finally, x is equal to half or minus 6. X is equal to half or minus 6. This is where we are drawing the curtain for today. Here is the assignment I have for you. Please make sure you lay your hand on the assignment. Practice, and I'm sure you are going to massacre every question there. So, don't forget to subscribe. It doesn't cost you anything. It doesn't. And don't forget to invite your friends to my YouTube channel at Idowu Math Class. Till we meet in the next class. Bye.